Hello and welcome back, guys. Okay, so get ready for your next video. We are covering a new type of design today. It's called randomized block. So it's different than completely randomized. Notice that there's still randomization involved, but this time we're going to be learning about something called blocking. So before we do example 4 on our outline, which go ahead and grab your chapter outline if you haven't already done so, I want to talk a little bit about the front of this. Okay, so we previously talked about the fact that in order to actually prove causation or make a claim, so to speak, you need to have a well-designed experiment, which means you need to have good control. Remember, control groups are used as a baseline of comparison. That is your buzzword right there. We also need to have good randomization, and we need to be able to replicate this a lot of times. Now, sometimes I have the word block not bolded here because sometimes you're going to find that your experiment doesn't go as well as you wanted it to. And that's because there's a lurking or something called a confounding variable. So a confounding variable is anything that confounds or distorts your results from being really the best they could be. If you find that you have a confounding variable, it does mess up your experiment, but you, in order to fix it, all you have to do is block on that variable and you'll get even better results. So again, very similar to lurking variable because it's not the explanatory and it's not the response, it's something else underneath that's distorting your data. So for number 4, we are going to do randomized block. And we are going to block on what we think is the confounding variable. So you're going to need some extra paper because we are going to do our math, but we'll also do a write-up on this one. So let's read the question together. The progressive type of cancer differs in women and men. A clinical experience to compare 3 therapies for this cancer was proposed: radiation, chemotherapy, combination of radiation and chemotherapy. It looks like these that they just listed are my levels, which means that my factor is probably the therapy for cancer. Design an experiment if you have 64 men and 42 women who have this cancer and have volunteered to take part in this experiment. So you actually already have your people that you need. Let's use the people who actually volunteered for this. Okay, so we're going to go ahead and talk about what the map is going to look like. How is it different when we block? Okay, well, it's going to start off the exact same as any other map that we'll do for experimental design. So we are going to start off very simply by saying that our experimental units so that's the who are we doing this on? These are the people or the cancer patients. So people with cancer. And we're given that we have a total. So here we're going to put the total number of people of 100. Oh, let's see, 106, right? So I would have to total these up together. We have 106 volunteers. Okay. Now, normally and completely randomized, the next step would be to randomly assign them to different groups. But we think that the fact that maybe they're men and women, somehow the progress of the type of cancer differs there. Okay. Now, I can't assign a treatment group. Oh, you're a man, you're a woman. Okay, right? I can't do that as a treatment group, but I can separate the men from the women and then do the experiment. That's what blocking is all about. We think that being a man or woman is confounding the results of this experiment. So what we're going to do is we are going to first block. If you are a man, you will be in one block, and there are 64 total. And then we're going to have block number 2, which is going to be our women. And we are given that we have 42 women volunteers. Okay, so this step right here, what I've just done is I've just done something called blocking. And I can write that across just like I would randomization. There's no randomization that's happened here. I'm just separating the men and women into two different groups, and then I'm going to run the same experiment. So now everything is like completely randomized design. You're going to have treatment group 1, 2, and 3. So what was my treatment number 1? Well, treatment number 1 was the radiation, okay? And I have to talk about how many people are going to be assigned to that group. How many people received radiation? Well, it doesn't take too much time, but what I can do is see if 64 is divisible by 3, okay? Because I would want to have the same amount in each of these groups. You know what? Instead of doing that first, I'm going to go ahead and write out what my 3 groups are. So the second one is chemo, and treatment group number 3 is the radiation / chemo combined. Okay. So to figure out how many people will go into each group, I'm going to do 64 divided by 3. Oh man, it's not divisible by 3, Mrs. Patrone. I can't have 1/3 of a person in each group. You're right. Okay. Which means your groups are not going to be even, but we're going to do our best to make them as even as possible. What if I put 21 into the first 2 groups? How many would that leave me left over with? Okay, so if I did 64 minus the 42, I would have 22 in my last group. That's okay. You're not going to split up the group with decimals. You're not going to have half a person or 1/3 of a person. You might just need to have 1 extra person in one of your groups. The other thing you could do is maybe turn away one of your volunteers, but you would need to find an unbiased way to do that, because who knows what they would claim. Oh, they didn't accept me for this. Okay, but in this case, we want to do the experiment on all these cancer patients because we want to help them if we can, right? Treatment number 1. Now, notice that I'm not putting this as treatment group number 4, because the 3 types of treatment groups that women can be assigned are the same 3 treatment groups that men can be assigned. So I'm going to say treatment number 1. These women are still going to be assigned the same thing as this, radiation, as the men. Treatment number 2, chemo. Treatment number 3, that's my combo treatment. Okay. Now, let's see if we get more lucky here. Maybe the number for women, 42, is divisible by 3. Now, if you remember anything from math, there is a divisibility rule. If you add the digits, 4 + 2 is 6. 6 is divisible by 3. So yes, 42 is divisible by 3. So we've got 14 that we can assign to each group. Now that works out just perfect. Okay. Now I want to just take a second to explain here what's going on. So what's happening here is both men and women, 14 women, 21 men, are both being assigned to radiation. They're still a part of the same treatment group. It's just that they are representing women or men, okay? But they're still together representing the radiation group, okay? Treatment group number 2, we've got a nice representative sample of men and women for treatment number 2, which is chemo. And the same for the combo group as well. So really the idea here is you do want to split them up, split up the men, split up the women evenly, so that both variables are represented, but also so that what you can see is that you have just some in each of the groups still belonging to the same group. Okay, so let's go ahead and finish this out now that we know all of our groups are being represented proportionally. Sorry, what I was trying to say a second ago was that if I added up the number of men, which is 21, to the number of women, 14, that would be about 35 people. Each of my groups have about 35 people. So each of my treatments have about 35, except for treatment 3, but 36 is not too different. So we're going to take all of our data Again, we always just combine all the groups that together, and we are going to take our response variable and we are going to measure and compare it. Now, what we're really checking to see is if these cancer cells if they've progressed or what's happened here. So we're going to measure and compare the cancer cell progression. Okay, now I want to just take a second to reflect on what we just wrote. One thing that we need to add here is that randomization is going to be used. Once we've blocked between men and women, we are going to randomly assign our men to each of these groups. We're also going to randomly assign our women to each of these groups. Okay, talking about the blocking, we don't have to write this on every single write-up, but I have a really special note that I would like you to make about blocking and its importance. Okay, what is blocking? Well, just like I've mentioned before, this kind of design is similar to stratified random sampling. Stratification reduces variability. So the same is true when we talk about blocking. Why do we block on men versus women? Well, we believe that that's a variable that's making a difference. So if I block on that variable, I'm going to get more homogeneous information among my groups, meaning that there will be a reduction in variability. So I will block to reduce the variability due to the confounding variable of gender. Okay, awesome. So this sentence in itself is an important sentence, just stating why we're blocking. That's oftentimes an AP question. Why would I block on gender? Well, it's going to reduce variability because I believe that gender is somehow confounding the experiment. So let's begin our experimental design write-up. Okay, so what we're going to do is start off the exact same way we have. We're going to do little 5 W's, include a little bit of context of what kind of experiment, what we're doing our experiment on, really. Okay. Okay. So there is a particular type of cancer and we would like to investigate how, we could say here, how treatments, therapies is the word they use, how therapies affect the progression of cells. Okay, probably a different way. You could also say the same thing. Okay. Now, on the AP exam, you want to state what kind of experiment you're going to create. You can, if you want to be fancy, you can add in the sense of why you're blocking it, why it's a randomized block experiment, but usually they'll ask a specific question where you have to answer that. Okay, so there's a particular type of cancer. We would like to investigate how therapies affect the progression of cells by designing a randomized block experiment. And that's where if you wanted to say why, if you wanted to say I'm blocking on gender, then if you want to add in that sentence there, you can. Okay. Now let's talk about the volunteers. So we have 106 volunteers. So 106 people with cancer volunteered to take part and let's see, did they say anything here? Yep, okay. In this experiment. And I could maybe specify where I'm going to get these 106 volunteers from. This is the part I can kind of make up. From local health care clinics, for example. I will block. Okay, I'm really just writing from left to right. So I'm going to talk about blocking now. I already talked about this. So I will block into men and women groups. Then I will assign numbers 1 through 64. So I'm going to talk about my men group first. To each man. And write the numbers on identical slips of paper. So I'm doing the magic hat. And place into my magic hat. Okay, now this is where I can use that fancy sentence. Shaking between draws and without replacement. That's always a good way of kind of saying that you're going to be doing the randomization. You're going to do it the same way every time. So the first 21 men will be placed into treatment number 1 with radiation. The next 21 men. So again, what I'm doing here is I'm looking from bottom down. So the first group is radiation, the next group is chemo, the next group is going to be the combined. So the next 21 men will be placed into treatment number 2 with chemo. I could put chemotherapy here since they actually wrote it out in the problem. The remaining men will automatically, we don't need to pull their names out, it's just whatever 22 names are left. So the remaining 22 men will automatically be placed into treatment 3 with the radiation and chemo combination. I will assign, now I'm going to have to go into women. So I've talked all about how I'm assigning men. Now I'm going to jump into my next block. I will assign women. And I'm going to go ahead and write it all out completely again. Okay. Yes, because remember, we're writing this as for someone who could replicate it, right? So we might know in our head, oh my gosh, I already know what I want to do with these men and women, but we're writing it specific instructions like a recipe so that someone else could follow and do the same thing of what you had in your head. I will assign women numbers 1 through 42. And write them on identical slips of paper and place into my magic hat. Shaking between draws, so that's that same sentence. And without replacement. The first 14 numbers drawn, or the first 14 women, will be put into treatment number 1 with radiation. Okay, now what I'm going to do here is I'm going to put a big star that says that you really need to make sure that you do the rest of the steps there. I'm not going to walk through all of these steps right now, but you would write out the full part of this if you were doing homework or if you were doing it on the AP exam. Okay, so now we might want to take a second to think about blinding and placebo. Maybe it's not so important for patients to necessarily know. We could design our experiment so that they would be blinded. But between radiation and chemo, I have a good feeling they're going to know what there has. There may not really be a way to blind that. Placebo, these are patients, cancer patients. I really feel like we need to give them something because they're suffering from cancer. So giving some of the groups a placebo wouldn't necessarily make sense in this problem. So we can talk about that if we'd like to. So I'm just going to say here, blinding and placebo will not be necessary. Now, we do want to talk about some things that would maybe control and help our group. So what are some control factors? Maybe the diet that they have. We may want all of our cancer patients to have the same diet. Also, exercise might also affect cancer cell progression. So having them be on the same exercise routine could really help to eliminate any extra variables that could be affecting their cancer cell progression. So the subjects or the cancer patients will eat the same. And exercise the same amount. Okay, now, however long a cancer radiation, really we want to make sure the amount of time is sufficient to really see if there has been progression. So maybe we could say 3 months, 6 months. So after 3 months, I will hire an unbiased oncologist to measure. Okay, now I'm going to go straight back into my design. So I've talked about all of my treatment groups. I've talked about randomization, blocking. Now we've got to talk about measuring and comparing cancer cell progression. After 3 months, I will hire an unbiased oncologist to measure and compare the cancer cell progression of each patient. Woo, okay, I know that was a ton of writing, so shake out your hands if you need to, but that's a good, well-designed experiment. Anyone could replicate this, assuming that you could, of course, hire and meet all the demands that are being met here. But as far as clarity goes, we have a very clearly designed experiment. And again, this is called randomized block design. Thanks for listening.